going to read each scenario. We're going to determine the best course for evaluating the total number of possibilities. We're going to show the formula for the method and evaluate. So when I say determine the best course, we need to ask ourselves those questions that we were asking in number 3. Whether we're told to or not, we need to recognize that they're important. So let's do that in number A. The number of ways to rearrange the letters in Florida. Does order matter? I think so. I think LRODAF would be different from ORAFDIL. To me, I think of this arrangement and this arrangement is completely different. So order matters. And by the way, writing out an example is a great way to answer that question for yourself. Write it out in 2 different orders and think whether or not it mattered. I think it matters. Order matters. The other question we want to ask is repetition allowed? If someone said rearrange the letters in Florida, you cannot write LLLLLORI. I'm pretty sure we did not rearrange the letters in Florida when we did this. So I think no repetition. Now that we've asked ourselves these questions, we know, hey, order matters, no repetition. This is permutations. We're selecting the appropriate tool because we've asked ourselves some important questions. This is specifically pick 7 or 7 factorial. And then I don't know, some of these we've done so often, you may memorize what 7 factorial is. It's probably a good idea just to write out the steps anyway, just in case you can get partial credit, but it's 5,040. Let's look at B, the number of ways to choose from first place, second place, and third place from 20 students at a dance competition. So, does order matter? I think so. If first place was Zaire, second place was Christy, and third place was Una, I think that's different from maybe saying Una's in first place, Zaire's in second place, and Christy's in third place. I'm pretty sure Una, Zaire, Christy would be a different decision than Zaire, Christy, Una. So I've written out an example. We've decided that order matters. Is repetition allowed? Well, you can't give Una first place, Una second place, and Una third place. And you also can't give Zaire first place and then Christy second, Christy third. It would make no sense to repeat. So now that we've thought about an example, I didn't write the example, but we at least thought about the example. Order matters, repetition matters. So we're still in a permutation situation. The only major difference is we're not going to multiply all the way down. It's not just going to be 20 factorial because we're not deciding on all 20 positions. We're just deciding on first, second, and third. So this is 20, pick 3. The short calculation would just be 20 choices for first. Once we decide on first, 19 for second, 18 for third. This is really the result of 20 factorial over 20 minus 3 factorial, which is 20 factorial over 17 factorial. But what happens is when you write out 20 factorial and you write out 17 factorial, you start eliminating all those common factors. The only thing that's going to be left is that 20, 19, 18. So that's the appropriate kind of final calculation that we have to do. So we have 6,840 ways to decide on first, second, and third place. Like I said, the hardest part is deciding order and repetition. And the easiest way to do that is just to write down an example in different orders or write down examples where things repeat and think about if it makes sense. It clearly makes sense that Zaire in first place and Zaire in third place would be different. It clearly makes sense that we cannot go Christy, Christy, Christy for first, second, third. So that's how we know these things and we decide on permutations. So C, the number of possible ways to form a group of 4 students for a project. from 16 possible choices. So does order matter? Well, you know, if I put, let's use our friends again. If I use Zaire, Una, Christy, and then we need one more, so let's go with Alex. If I put these 4 students to work together on a project, I'm pretty sure that's the same as doing Alex, Una, Zaire, Christy. If I said, Zaire, you're going to work with Una, Christy, and Alex, there's no way Zaire would say, no, 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 I want to work with Alex, Christy, Una. So order does not matter. No way, Jose. Okay. Is repetition allowed? I think probably not. There's no way I can make a group of Alex, 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 Christy. So this is no repetition. Order does not matter, no repetition. So what that actually means is order does not matter, no repetition. That's exactly what combinations are for. Just like order matters, repetition matters, is permutations. Order does not matter, repetition matters is combinations. So this is really just 16 choose 4. There's a couple of ways to write out that notation for it. Either one of these is fine. There's a way to calculate 16 choose 4. 6 factorial over 4 factorial, 16 minus 4 factorial. In the interest of time, we're just going to kind of cheat and use the button in our calculator. But most importantly, like I said in class today, this is really the heart of getting full credit, is writing the full choose formula. How you choose to simplify it, I'm not going to be too picky on. So there are actually 8,020 different groups I can make if I had 16 students to choose from and I needed to make groups of 4. So I hope you guys can appreciate how tough it is to make a seating chart, right? I have a lot of choices to make. So that's A, B, and C. For the next 3 letters, just click on the next video. I'll try to work them a little more quickly. I'm going to assume you've watched this video, so we're going to just do order matters, repetition. We're going to do that really quickly in the next section.